Hey, I want to talk about finding powers of complex numbers with Moivre's theorem. I think that's how you pronounce it. Correct me if I'm wrong. So let's look at Moivre's theorem. So what really is it? If we have some complex number to the power of n, right, that is equal to our complex number in polar form, all to some power of n, which is equal to our modulus to that power of n, all times cosine of theta times n plus I sine of theta times n. Now, it's pretty easy to understand why this actually works if we understand how you multiply complex numbers. Let's remember that if we have some complex number, right, with a modulus of r1, right, and then we have cosine of x, right, plus I sine of x, right, and we're multiplying it times r2, that's going to be our modulus, cosine of y plus I sine of y. Let's remember, when we're multiplying these complex numbers, what do? Well, with their moduluses, whatever, right, we multiply them together. So this is going to be r1 times r2, right? And then with their angle, we add the angles together. So this is going to become cosine of x plus y plus I sine of x plus y, right? So remember, that's what we do when we're multiplying complex numbers. But what happens when we're just multiplying it times itself? Well, let's think about it. If we have some complex number, right, r, let's rewrite it, cosine of theta plus I sine of theta, right? And we multiply it by itself n times, right? We're multiplying it times itself n times. So let's ... right? Let's start multiplying it by itself n times, right? Well, every single time we have an r down here, we're multiplying r by that next one. So that is just r to the n, right? And then remember, with the thetas or angles, right, every single time we go down, we're adding that angle to itself. So if we have some x, we add the y, and then we have another angle, z, we add the z, x plus y plus z. In this case, it's all just theta, right? So theta plus theta plus theta, that's 3 thetas. That's 3 times theta, right? So we can say this is n times theta. N theta, right? And we can say this is the same for sine, right? We have n theta. So that's a good way to understand why this actually works if you know how to multiply complex numbers. But let's take a look at the actual usage of it. Well, let's say we have some complex number, right? And let's say it's let's say we're cubing it, right? So this is equal to, right? And let's say z equals the complex number. Let's say our modulus is 5 cosine of pi over 4 plus I sine of pi over 4, all right? Then what do we want to do? Well, if we're let's cube it, all right? We're going to raise it to the 3rd power. So the first thing we want to do is let's take a look at the 5, right? Well, 5 cubed is 125. 125, right? Then we have cosine. Our theta in this case is pi over 4. Remember, whatever n power is, we're multiplying it by that. So pi over 4 times 3 is 3 pi over 4. Cosine of 3 pi over 4, right? Plus I sine, and then once again we multiply by 3 pi over 4. So we have just cubed said complex number. And then I'm going to leave it up to you guys. Put it back into rectangular form. Because right now it's in polar form, put it into rectangular form. So I hope that summarizes real quick what the Moivre's theorem is about and how it can be used. Probably in the future I'll make a video on the roots of complex numbers and the formula for that. And then I'll also prove the Moivre's theorem a little bit more rigorously in the future. But thanks for watching.